Right guys, welcome to my new video. We've got new camera, light source, new microphone, so hopefully it's going to be a bit easier to watch. You'll be able to see and hear a little bit better. Right, today we're going to be making a fun number card trick to do on your friends. Now if you remember at Christmas time, you sometimes in the crackers get those little sets of cards that have loads of numbers on them. You tell your friend to choose a number from one of the cards, give you all the cards with that number on it, and then you tell them which number they chose, and it's magic. So we're going to be using binary numbers to make a set of those cards for ourselves. Now if you can't remember binary numbers, not too taxing stuff. If you remember from school, you had your columns, thousands, hundreds, tens and units, this is 10 cubed, 10 squared, 10 to the 0, okay? And then you would have a number, it might be, I don't know, say 326. And then this is really 3 times 100 plus 2 times 10 plus 6 times 1. But we write it like this, okay? And use the column, the corresponding column, to tell us how much we need to multiply by. Now binary is the same, except instead of having tens in our columns, we have twos. So you might have 2 to the 4, 2 to the 3, 2 squared, 2 to the 1, and 2 to the 0. And then your number might be, you can only have zeros and ones, because then you move one up once you get to 1. So this number would be, for example, 1 times 2 to the 3 plus 1 times 2 to the 1 plus 1 times 2 to the 0, and that's equal to 8 plus 2 plus 1 is 11. Okay, so that's how we write 11 in binary. But you don't need to have ones and zeros. We use ones and zeros because that's how we count. But you could have ticks and crosses in each of the columns, or like a computer has, current flowing or not, or we could have just different colors. So this could be red, green could be yes you please use that column, and red could be don't use that column. Or we could have cards. We could have cards with numbers written on them, 2 to the 4, 2 to the 3, 2 to the 1, and 2 to the 0. Okay, and then I could say, think of a number, put it in binary form, and give me the card corresponding to ones in the columns with ones in. So you would give me this, you would think of 11, and you would give me this one, and this one. But that's not very exciting. You would know what I'm doing. I'm telling you what I'm doing, right? If instead I was to write 11 here, and 11 here, and 11 here, but not here or here, and then I would say, give me the cards with your number on, and you would give me this one, and this one, without knowing what you were doing, see? Right, so to set up the cards, make your own set. You start off with cards with these two, that's 2 to the 4, 2 to the 3, 2 to the 2, 2 to the 1, and 2 to the 0. And then what you do is you go through the numbers you can go up to 2 to the, depending on the number of cards, you can go up to 2 to the n minus 1, where n is the number of cards. So in this case, 2 to the 5 is 2, 4, 8, 16, 32, minus 1 is 31. So we can count up to 31 with 5 cards. If you want to count to 32, it's like I said, you move one more column to the left, so we'd need another card. So we can count up to 31. So what we're going to do is write the numbers 1 to 31 on the cards, corresponding to the columns where there would be ones in the binary form. Okay, I'm going to do that now. Well, I'll start off with you, and then I'll skip to the end. So 1 only appears there. There will be zeros in every other column. 2, again, there will be a 1 in the second column, zeros in every other column. 3 would have a 1 in the first column and a 1 in the second column. 4 would merely have a 1 in the third column, which is already written there. 5 would be written like this. So you can see how we're going now. 6. So if they chose 6, they would give you this card and this card, not any others. Okay, so it's because it's only written on these 2 cards. 7, 8 is there, 9 is there, 10, and so on. 30, 30, 30, 31, 31, 31, 31, and 31. Right, so there's our 5 finished cards. So as you can see, there's 16 numbers on each card, and then you would choose, for example, let's say 23. 23 is on this card, 23 is on this card, 23 is on this card, and 23 is on this card. So the way you figure it out is you just, as we did with the columns, you just add this number here all together. 16 plus 4 plus 2 plus 1 equals 23. So that's how you do the trick. This gets a bit tedious. I have written a bit of Python code. I'll pop it down below. That will just give you a list of all the card numbers. You can then print that off or whatever, or you can do it longhand to get an idea of what you're doing. You can do it with more cards. The more cards, the more impressive the trick looks. But the longer it takes to write them all out, again, use the Python code. It runs up to 10 cards, which is pretty crazy. It means you've got to do more adding up in your head as well to make the trick work. But people will be suitably impressed, I'm sure. And that's it for today. I hope you enjoy doing this trick on your friends, and I'll see you next time.